Antarctica, frigid, barren, seemingly endless. On December the 3rd, 1961, a 63-year-old woman by the name of Andrea Barnes set off single-handedly across this barrier of ice. On December the 18th, the weather turned against her. A week later, on Christmas Day, radio contact was lost. Miss Barnes was never seen again. This was to be the final leg in a journey that had started for her nearly half a century before. A journey ending in apparent failure. She had not succeeded in proving to the world that the Earth is flat.
It has a flat top and it's shaped like a top. There's a certain amount of depth here because there must be a vertical axis on which it rotates, and the stability of the mass would indicate that there must be some depth, or wobble could very easily occur, and we know that there is none.
It's a commonly held misconception that the Earth is a spherical object that revolves around the Sun. But the fact is, of course, that the Earth is a circular dish surrounded by a barrier of ice that explorers like Andrea Barnes have been attempting to penetrate for centuries. In 1585, amid a storm of controversy and under cover of darkness, an adventurer by the name of Afton Marcella stole out of London in hopes of being the first to reach the edge of the Earth. But he was unprepared for the extreme conditions. His crew was plagued by scurvy and frostbite. Food supplies ran low. Marcella was forced to turn back before setting foot on Antarctica. So ended the first recorded expedition. But the controversy goes back much further than that. Since long before the dawn of recorded history, we've been trying to understand the world around us. And we've constantly turned to the sky for answers. By unlocking the keys to the stars, the sun, and the moon, it was reasoned, we would learn more about the Earth. So we've remained ever vigilant, turning both our persistence and our technology to the task at hand. But the conclusions have not always been particularly well thought out. 2,000 years ago, an Egyptian scholar by the name of Eratosthenes performed an experiment that he claimed proved the Earth to be a sphere. However, there are serious doubts about the accuracy of his data and his scientific procedures. Dr. Leo Ferrari explains.
Oh, the Eratosthenes experiment is an experiment supposedly conducted in the 1st century, whereby this ingenious person was supposed to have proved, I say that in quotes, that the Earth was a sphere of some 4,000 miles radius. Eratosthenes one day noticed that the sun was directly overhead in Syene, whereas he noticed that on the same day, at the same time, the sun made an angle of 7.2 degrees to the vertical at Alexandria, which was some 530 miles away. How did Eratosthenes in the 1st century know what the sun was doing on the same day in two places which are 530 miles apart? One can take all those same data, knowing that the Earth is flat. In one place you have the sun directly overhead, and at another place at the same time, at 530 miles away, let us suppose that it does make an angle of 7.2 degrees to the vertical. Then we have a right-angled triangle, which it can be easily shown that the sun is some 4,000 miles up in the sky. These superficial, even, considerations show that it's impossible. The whole thing, it's a story, a fairy story made up and mindlessly repeated in textbooks.
Fortunately, not all scientific arguments are based on such questionable research. The Greek astronomer Ptolemy determined to everyone's satisfaction that the Earth is flat, circular, and the central body in the universe. His theory went unchallenged for 1,200 years. Not surprising, really. One need only look around. However, the notion that it was some other shape gained some acceptance during the Renaissance. These were impoverished times. Most writers, artists and scientists could not support themselves through their work. They depended on the patronage of the upper class. Consequently, creative and original thinking men let their imaginations run rampant in order to attract support. The fact that Leonardo da Vinci designed a flying machine late in the 15th century confirms that the sky was the limit to which scientists would go to impress potential backers. And an examination of the shape of the Earth was a popular theme. In 1543, the Polish astronomer Copernicus suggested the bizarre notion that the Earth is a round ball that circles the sun. But his book emphasized it was only a hypothesis. He further avoided controversy by withholding the book for 13 years, and then by dying on the day it was published. Edmund Halley, the highly esteemed British astronomer, best known for the comet named after him, proposed that the Earth is made up of several concentric spheres, each supporting life, placed inside one another in the manner of a Chinese box puzzle. Marshall B. Gardner, however, insisted that the Earth is completely hollow except for a small sun that lights the interior. The argument, for all practical purposes, came to an end when the Church of England was established by law during the 16th century. They rejected many laws of the ancient Catholic Church, and to appear forward-thinking, they embraced many radical scientific notions prevalent at the time, including Copernicus' round Earth theory. With this endorsement, the theory found its way into the schools, which were then largely controlled by the Church. It has remained there to this day, and many children have accepted it without question. Andrea Barnes was not one of those children. Born into an Ontario farming family in 1898, Andrea was a bright child who spent much of her time learning about the world around her. She was inquisitive and precocious, and much to her teacher's dismay, she fervently believed the global Earth concept was nonsensical and easily refuted. Many scientists agree with her and are amassing evidence to carry on her work.
There's all kinds of proofs right around you that show that the Earth is flat. A very simple one to think of is that we use plumb bobs to build buildings. In other words, to get the wall of a building going straight down, you'll take a string with a heavy weight hanging from it, and you'll make the building follow that string. That plumb bob will point to the center of a round Earth. That means that if you imagine that this was the correct Earth, you can imagine a plumb bob held here would point in that direction, and a plumb bob held here would point in that direction. That means the buildings would be bigger on the top than at the bottom.
It would also mean that boats would constantly be sailing downhill. And invariably, in any discussion about the shape of the Earth, the first argument used in support of its rotundity is that as ships sail out to sea, the tops of their masts are visible longer than the hull.
The fact is, of course, that the light rays from the lower part of the ship are no longer reaching the shore. When we consider that so eminent an authority as Einstein postulated and indeed proved that light rays bend perceptibly in gravitational fields, it should not be surprising that the light rays from the lower parts of the ship do not succeed in reaching the shore, are incapable of entering the eye of an observer, and so the particular part of the ship from which those light rays come is not seen.
But it was hundreds of years before Einstein's time when explorers like Sir Francis Drake and Ferdinand Magellan were pushing out the boundaries of the known world. And it wasn't easy. As they ventured further and further from established trade routes, the fear of coming to the edge of the world and falling off became a very real one. Sailors became increasingly apprehensive about joining such an expedition. So Copernicus' notion that the Earth was a ball you couldn't fall off of was readily embraced by businessmen. And when Magellan's crew claimed to have circumnavigated the globe in 1522, it was seen as a new piece in the scientific puzzle. But more importantly, it was seen as a strong psychological boost for free enterprise. It's also been seen as a huge publicity stunt.
The sailor thinks that he's traveling around the Earth this way, when in effect he's traveling around the Earth this way. And he's creating a circle. He's moving in a continuous direction around. He goes through the various parts of the circle, and he comes back where he started from. Swim around this way.
Does running round your neighborhood prove that the neighborhood is round?
By the time Andrea was in her teens, her brother Andy had already decided to go into the transportation business, and many of her friends had turned to nursing as a vocation. But Andrea devoted her time to exploring the world around her and to questioning. She was vehemently opposed to the use of globes in schools and formed a group to protest what she referred to as a load of old codswallop. They demonstrated in a manner they felt symbolic. But Andrea soon realized the only way people would listen was if she made a trip to the edge and brought back proof. And so, on her 16th birthday, she set off across the snowy deserts of Antarctica with little more than a borrowed pair of skis. However, like Marcella some 300 years earlier, she was unprepared for the harsh conditions and was soon forced to turn back. She tried to raise money for a larger expedition, but her cause was overshadowed by the outbreak of World War I, and it became more important to worry about maintaining one's stake in the world than arguing over its shape. Although they never met, Andrea's mentor was this man, Samuel Burley Rowbottom, better known throughout the scientific community as Parallax. In 1881, he had published this book, Earth Not a Globe. Outlining dozens of experiments performed over many years, it quickly became the standard authority for anti-globularists. Perhaps the most significant experiments were those carried out on a canal known as the Old Bedford Level. Located in Cambridgeshire, England, the canal is perfectly straight over an uninterrupted 6-mile stretch. While there, Parallax conducted many experiments, all towards one conclusion, to prove that the surface of the water in the canal was indeed perfectly flat. In one experiment, a boat carrying a flag rowed from one bridge to another 6 miles away. An observer with a telescope placed 8 inches above the surface of the water found that the flag and the boat were distinctly visible throughout the entire distance. If the Earth is a sphere with a circumference of 25,000 miles, then over a distance of 6 miles, the second bridge should mathematically be 16 feet below the observer's eye line. But in spite of the mathematical evidence, any further attempts to restore belief in the flat Earth seem doomed by one of the supposed great moments in modern scientific achievement. At last, after thousands of years of uncertainty, man was able to get far enough away from the Earth to have a good look at it in all its resplendent beauty. It did appear curved, and photographs were brought back for all to see. However, according to experts, these photographs are much less conclusive than one might think.
Einstein told us that light actually is attracted by gravity. In other words, the path of light is not straight in a strong gravitational field. So, astronauts looking at the Earth see a curved Earth, but what they don't realize is that it's not the Earth that's curved, it's the light taking a curved path from the Earth because of the strong gravitational field of the Earth that makes the Earth look curved.
So you're saying that those photographs from space that the Apollo mission brought back don't represent the Earth as it really is?
Of course they represent the Earth as it really is, as seen by curved light. And so those photographs from space are entirely correct. And It's just that what has to be taken into account when we take data from those photographs is that light traveling through space is curved by gravity. And so it'll make straight things appear curved. And you know, it'll also make curved things appear straight. So you have to be very careful when you use light to measure things in a very high gravitational field.
They're going up, and the astronaut thinks he's leveling off this way, going around, when in effect he's leveling off this way, and he goes around in a circle, this, like so. The farther out he goes, the less he sees of the Earth. He makes a bigger circle, he can make as big a circle as he likes, and which is in effect exactly the same as if he was going around the world this way, and going out farther, he makes a a larger orbit.
Through time-lapse photography, the velocity of these clouds has been dramatically increased. While they were actually drifting over the mountains at approximately 27 miles per hour, they now have the appearance of moving at well over 100, 4 times their normal speed. If the clouds were stationary and the Earth was revolving underneath them, this is how it would appear if the Earth was spinning at 100 miles per hour. Yet we're told that the Earth is spinning at 10 times that speed. Consider this. Those who maintain that the Earth is a globe that spins suggest that people standing at the equator are being whirled around at approximately 1,000 miles an hour. They further maintain that the Earth is spinning around the Sun at a speed of 67,000 miles per hour, and that our Sun is supposedly racing around the center of our galaxy at some 600,000 miles per hour. And yet, you and I both know that on many days it's possible to stand outside without a single hair being messed up by the breeze.
You put your hand outside a window of a car which is going even at 80 kilometers per hour, a terrific wind goes blasting by and pushes your hand back. Imagine putting your hand outside the window of a car that's going 1,600 kilometers per hour. You just take your hand right off.
With a sphere of 4,000 miles radius being spun round once every 24 hours, a little bit of calculations will show that that person there is being spun round at about 1,000 miles an hour and doesn't know it. I mean, this is obvious nonsense. You go on a merry-go-round and it goes, I doubt, more than 10 miles an hour, and you get off all dizzy. You mean to tell me that people can be spun round at approximately 1,000 miles an hour and not know it? Why, if this is so, this whole room that we're in is supposedly being spun round at something of approximately that order of speed, and we don't know it?
There's all kinds of evidence for the phenomenon of what's called continental drift. This means that the continents are able to move as if they're floating on a fluid. Now, if the Earth is spherical, if it's spinning, anybody knows that if this is spinning very, very, very fast like that, that the continents should all be located at the equator, because centrifugal force would move the continents from the poles to the middle. One of the real big problems that maybe is a little bit easier to understand, sound doesn't travel nearly that fast. So, for example, if you're at the equator and you wanted to shout to warn somebody, it's quite possible they could never hear you, because if you're shouting, say the Earth was spinning in this direction, and you're shouting in that direction, the sound could never catch up to the person who's, of course, being carried away by the Earth.
In October of 1929, Andrea again tried to focus the world's attention on the controversy by proving the notion the Earth spins to be absolute nonsense. It was reasoned that if a dirigible was to go aloft in England and hold itself perfectly static, then by the accepted theory the Earth should rotate underneath it and New York should come into view some 4 or 5 hours later. In fact, England was never lost from view. The dirigible eventually ran low on fuel and had to land. Andrea insisted she had made her point. But New York wasn't paying attention that day. The stock market crash monopolized the headlines then and for some time to come. Andrea had again been upstaged.
Instead of going, spinning around this way and going around, it goes up and down. Now, when the Earth is up here, and this is the Sun, no rays, dark. When the Earth is down here, daylight. When the Earth is here relative to the sun, and it's going up, sunset, into night. Reaches the top of its path, comes back down again, and sunrise.
Now, an interesting thing happens at the ends of the Earth. You see, when you go from on a car trip from point A to point B, you're moving through what's called space. And it takes time to get through space. But if there is space, there must also be non-space. It's kind of like saying, if there's wet, there must be dry. You can't have one without the other. It's obvious. So when you get the end of the pizza model of the Earth, you're actually moving from space into non-space. Now you can move through non-space in no time. See, it takes time to move through space, but it takes no time to move through non-space. So a lot of things are affected by this. For example, satellites, as they cross the Earth, they will then go into this non-space region. They will instantly then be able to reappear back where they started by taking a non-space route. The moon does this, the sun does this, and stars even do this at a very, very slow rate, moving from space into non-space and then reappearing back where they started from. This is due to probably of reflectivity and complementarity that is a well-known phenomenon.
By November of 1938, Andrea was prepared for her second attempt to reach the edge. A consortium of financiers were providing her with a plane and a large enough crew to make a legitimate go of it. And so, once again, an optimistic Andrea found herself in Antarctica. And once again, fate was against her. A freak spring blizzard took them by surprise. They were unable to leave base camp, much less make a trip to the edge. The entire expedition was very nearly wiped out. That was the last attempt Andrea made until 23 years later, when she set off alone by snowmobile in 1961. Until recently, that was the end of the story. Early this year, a researcher stationed in Antarctica to study weather patterns found a snowmobile partially buried in a snowbank. It had run out of fuel and there were no signs of Andrea anywhere. But he did find these, a camera and a note. The note says only, "I have been there. The debate finally comes to an end. Signed, Andrea B." It had survived the frozen elements for nearly 30 years. Unfortunately, the researcher inadvertently opened the camera, exposing the film inside. Any pictures were lost, and Miss Barnes' trip is still very much shrouded in mystery. There was no description of what she had seen or how far away it was. But if we are to believe the note, then Andrea Barnes was very likely the first person in history to visit the edge of the Earth.
What you don't know, you eliminate. And that's in my opinion, is what the globular Earth theorists have done. They've just eliminated what they didn't know. The more honest approach is the flat Earth approach, where you say, well, we don't know what's at the ends, but the ends are there.